session. It started at 11, so we have about 30 minutes left. So after 30 minutes of this, then we will just continue. So I believe, I always say I believe, that most of you are familiar with, let me put this at the bottom, are familiar with this presentation of the diagrams that we have. And also, this is not the only one, but it's the start one that we should at least know. And I will just run through this as fast as possible, okay? And so sometimes we refer to certain things as ray, vertex, and we have an angle. So we have one ray, we have another ray. A vertex is where two rays meet. So normal mathematics or English, a ray is what we basically call a line. Okay, so we have line 1, and then we have another line 2. Okay, let me just write that correctly. Okay, can I just ask a question? Is it okay that you guys can see my screen or you can't see my screen?
Yes, we can.
We can.
Okay, so let me continue. So also note that in these diagrams, the first ones that we have here, our rays, all right, they also have an arrow. When there is an arrow attached to the line, as in this diagram, this has now changed now to a vector. Okay, so stuff to write, but I'm trying my best.
So quickly re-explain, I don't understand.
Okay.
Yes,
Right, let's go back. So you get that this ray is called a line, right? It's a line going up and there's a line going to the right. You must say yes so that I know you can, at least I can proceed.
Yes, sir.
Okay, so this is when you have a line and a line where they meet is called a vertex. Okay, that vertex is like that point where the two lines meet. And where that two lines meet, it basically forms an angle. All right, so this is the start of an angle is in a 2D shape. Okay, we call this 2D because there's only two lines, one line and one line. Then they form a 2D, and then that's the first angle we can get. Okay, so what I have said now, we get the line, whenever a line has an arrow attached to it, can be an arrow, and sometimes it can just be a pointer like that. Whenever a line has an arrow or this thing, then this does not become a line anymore. In mathematics, we call that a vector. Okay. Now it becomes a vector. I will explain vector later on because the arrow tells us that the line is going into that direction. Okay. This other arrow tells us the line is going in that direction. Okay. The ones at the bottom, well, the ones over here, they don't have arrows. So they are not vectors. Okay.
What are they?
They are just lines. So a vector is a combination of a line and an arrow. Okay. So a vector has two things. A vector, it must be a line, yeah.
So is there a possibility that you can print us out this notes for us?
I will share it on the Google Classroom. All the notes. So I'm explaining to you in this way because of the images, but when we do a vector later on, you will see that vector has a size and direction. So the line will change to size, the arrow will change to direction. That's basically how we will just define it later on. But for now, for you to see something like that, it's clear that, okay, there's a line, there's an arrow, vector, okay? So I'm just explaining it like this for now, and then we go on. So here we have a 0-degree angle, okay? 0 degree means there are no degrees because both the red and the green line are in the same direction, so there's no angle formed, okay? The red and the green are on the same, there's no angle. So that's why the 0 degree comes. There's a question?
So is this also like the worksheet we got? Which paper is this one?
No, this is a new lesson.
Oh,
Yes.
okay.
Okay. Can I also just announce that you guys can, I will upload the videos later on, the recording, so that you can go back to everything, right? So that we at least cover as much as we possibly can. Please note, I'm explaining this.
Please mute yourself, stop.
Yeah, let me just quickly see. Who is?
Guys, can you please mute yourself unless you have a question to ask?
Yeah. Okay, I'll just mute it. All right. I just muted. So as I've said before, this is a 0 degree, okay? 0 degree because both lines are on the same, as we call it, axis, or on the same plane. They are basically on the same line. One is the line, one is a subline. Later on, we will talk about those sublines as well. On the other side, we have an acute angle. I believe you know what an acute angle is. Angles smaller than 90 degrees. We have a right angle, which is only 90 degrees. Obtuse, greater than 90, less than 180. We have a straight line. This is the most important thing you have to remember, guys. Honestly, like I don't know. Most of the time, for the rest of the things that we were talking about or going into, you have to know this by heart. Like you just have to know it. Everything, if there's a straight line, you know it's a 180 degrees. Wherever you see the box, the square box, the 90 degrees, you have to know. Angles that are smaller, you need to know you are going into that range, okay, for acute angles. Obtuse angles, greater than 90, less than. So sometimes with obtuse angles, we make use of this supplementary angles, complementary angles. We make use of those words later on. We just add them. And then this angle here, the reflex angle, greater than 180, less than 360. Okay, this is also important. And then a full revolution is 360. Okay, so whenever we get angles, okay, you in question papers, whenever there's angles or anything like that, you should get 100% because all the answers are given to you like already, it's on the paper. Okay. The questions that we are referring to is questions like this at the bottom. I'm now over here, right? Where we will give you, for example, this angle can be 120 degrees, all right? Then you should be able to find A, all right? Here at the bottom, it gives you an example. You know that this is on a straight line. Ignore that extra line going up. You focus on the straight line. The two angles are on the straight line. And I have B, which is 120. All I need is A, and it's easy to solve with algebra. Same with this one. This is now where we talk about supplementary angles, and we talk about complementary angles. Complementary form a 90 degrees. Supplementary, they add up to give you 180. Opposite angles are also there. We also have to know that if an angle is here and an angle is there, these two angles are equal. And the same as A is equals to B here, you should also note that A and this angle here is a straight line. So sometimes we ask you A and B, but we only give you here, for example, and say this is a 30-degree angle. Please find A and find B. So you have to know in these examples that, okay, if this is 30, this will be 180 minus 30, and that will be 150, all right? So this will be 150 because this plus this must give me 180. Same with this one, it will be 150, okay? Because this and this still makes a straight line. So 30 plus this gives us 180, and then that goes on like that. And then we have adjacent angles or angles that are here. I think we played around with some of the angles when we did the circle theory. But you also need to know how we tackle some of these angles here, okay? And there is one extra line that we normally give to certain learners, and I'll call this angle C. So whenever you see something like this, then you know that this plus this plus this must give you 180 degrees, and that is basically how you can also define it as such, or in a way. Sometimes we give you the whole, if I go back a few things, sometimes we give you this reflex angle, we give you this one, and we ask you to try and find the other ones over there. So that's also ways we can go to. All right. So enough on angles. That's just the first part of geometry that we would like to look at. We will still come back to other parts as we proceed, but for now, I just wanted to speak about some of the first angle properties, and then we will do a little bit of geometry as we continue every time, and then add the new topics, because the new topics I don't want to just leave behind and without us trying anything with them, right? So for now, I will close this and I'll clear the drawings. I will share this on the group as well so that you can have notes. All right, so I have this lesson here. It's on Loci that we are going to start today. And I just want to make sure that we all understand Loci. So it's also very important. Just gonna
So
move.
someone said your sound disappeared, right?
Someone said you cannot hear.
But you can hear, the rest of you can hear me. So then it's on that person's side. So let's ask for a rejoin. But just remember that the videos will be available, right? I'm not sure as to how much time we have left. Okay, let me just quickly check before this session ends. All right, we still have about a few minutes left. So I'll start with this one. So the locus of a point is that the path traced out by a point has moved through 2D or 3D shapes, okay? In locus problems, you have to find the path of a given rule or rules, and that's basically what we are referring to, okay? So the locus of a point at path traced out, okay, is as follows. We know now we have basically perpendicular lines, okay? This is the, let me just hold on that one a bit. Let's just first look at this one. The locus of a point that moves so that it remains equidistant from two fixed points. That's basically a locus. Drawing locus means that the distance that we are referring to is always the same for any given points. That's the same distance everywhere. The perpendicular bisector of a line joining both 2 points, the perpendicular bisector, by now we know, we have done examples of perpendicular bisector. Now a question could come up like this: draw the locus of the points that remain equidistant from point A and point B. Okay, so if you have to draw a locus, that means join the points first with a straight line. It's like one of the questions we did last time where we had to join point A to point B to first find out that is now the line that joins point A to point B. You have to draw it in. Okay, so first we will draw that line, and then the first one is you will place the compass on the first point, hopefully in the center. All right. Once you have placed the compass there, you will stretch out your pencil to be more than half of the line. Okay, you have to now use your eyes to determine where is more than half of the line. So once you stretch it out to that place, okay, you will start to draw a small arc. It's like a small arc of a circle, not a big one, that is over the middle, that goes into the other side of B and also to A on this side, and you will draw it on the other side at the bottom. All right, and you should not move You should not resize it or close it. You should keep the compass the same at all the time. It should not be moved, okay? So that's the first one we will draw. Then we will place it on B and do the same thing without changing anything, all right? Without changing anything. So if the line, if the compass, the distance of the compass that you've opened up is the same, then it should make a cross. It should cross this one. You should not move it. If you move it, then it will not be correct, okay? When you start with one measurement, stick throughout. So you do another one on top and another one at the bottom, like that. So once that is done, where the two lines meet, there is a point, okay? That's a point, and this is a point. So we will join those 2 points together and try to make the line as long as possible. And that will be basically the 90 degrees that we form, okay? So the locus of a point that moves so that it remains equidistant from 2 fixed lines as shown. So sometimes we don't ask you equidistance, we just ask you draw the locus of this angle over here so that we can now at least know, all right, where is the middle part of this angle. And that is what we will look at now, how we will join this one. All right, this also works for triangles. Sometimes we join point, let me just draw it in. Sometimes we join point C and B together, right? This can be in a question. You ignore that point and you focus on the one that we want you to draw, okay? So the one we want you to draw is there. And normally you will notice that once you draw in this line over here, at some cases, it will be the midpoint of BC, right? So that's sometimes how it will work. Sometimes it's not going to work. So it's not always a guarantee, right? So let's first see. So in this time, how we draw it, we place the compass at point A. So at point A, we will draw a type of an arc over here. I'm just gonna show you how we're going to draw. Once you place the compass at A, you will draw a small arc over here, and there's another small arc over here. Same, you don't keep the, you don't change the compass, you keep it the same. Once you have drawn those small arcs over there, then we will go to the next step. So I'll just let it play out so that we can at least see the steps that we have. Okay. So you can see the way I drew it was just make small marks. You don't remove any of the marks ever. When you are doing locus, all the marks must remain. Don't rub it out. So it is not a good idea to it is not a good idea to let me just do what to put in marks everywhere on the page, because we want the locus at least to show. So that's why we leave some spaces in here so that when we draw in the locus, we can at least see, okay, that is the locus that we have, all right? So once we have those two marks, the same as mine, it can be close, it can be far, it doesn't matter, your answer will be the same, all right? Once we do that, then we place the compass over here, and we make one mark over this side, another mark over this side. Then we do the same where the two marks will join, and then we will have a point. Okay. So sometimes you just use one, it's fine. If you use both, you will still join the paths all the way the same. Okay. So let me just remove that so that you can see the locus has been drawn. Okay. So once we get to that point where we have the two of them meet, we just join point A straight through that one, and that will be the locus. So this means the following. We have now created an equidistant angle. Let me just go back. We have created an equidistant angle. Just a small point. I just want to get my pen ready. And just clear the screen. I went a bit too fast. Okay, I don't know now. My slide is having a slight error, but I think it will. Let me just wait for it to finish loading. So it's very difficult to teach these things without doing it practically on the piece of paper. But we hope that you guys are following as I'm also talking about whatever it is. So this is unautomated, so it gives me a few minutes just to talk about everything. But I want to go back to that final point. Okay. But okay, it's not playing, so let's just try and see if we can continue with this one over here. All right, so the locus of a point by tracing it both, right? This is now the next one. Let's see. It's not playing. Okay. So this is one of the most common locus that we will ask you to do. And this is all the, let me just go back so I can just pause it when it's finished. So the locus here, this point means that all the lines, all these points, all the line that we will draw is the same distance from B to there as from A to there. This is now trying to draw a circle that is the same distance everywhere. If you take your ruler, this doesn't have a ruler, but if you take your ruler and you measure from this line to that point, okay, not white, but rather pink, from this line to that point over there is the same distance from this to there. So all these points are equidistant from A and B everywhere. And this is the end result of locus. If we can draw something like this, then we fully understand the locus. So it surrounds all the points of the line at the same distance everywhere. There's no place that the line is not the same, okay? That is what it basically means. Okay. I'm gonna clear this because it's gonna go to the next one. So this one is how it ends. All the lines are the same. And now we start with the construction, how we are supposed to do it, okay? So draw the locus of a point. Okay, so first we have to draw two parallel lines, okay? That is the same distance. The parallel lines do not exceed point A and do not exceed point B. So this line over here, if I have to measure it, this line over here is the same distance as this line over here. Okay, I'm now just moving differently so that you can see. So that's the first thing that we have covered. Okay, so the hardest part will be to draw the circle curve that we have. But from here on, if you can draw two parallel lines that does not exceed, sometimes we allow learners to a little bit go over so that you can have that space, and then we will rub out that excess one later on if we need it to be there. Okay, so once that is done, then all we need to do is you take the distance of where the line has stopped, and I have to put that in a color. Let me just make the pen a little bit big. We stopped here when we drew the two parallel lines over here, right? Then you take your compass, you can start at A or B, wherever you start. The other point was there, okay? Measure one point, the sharp point is on the end of the point. The pencil is at the start of the parallel line or the end of the parallel line that we drew. And then you just nicely draw a curved half circle there. It will join the 2 points. If the 2 points don't join, then these two lines are not equidistant from each other, okay? Then we do the same thing without moving the size of the compass or the length of the compass. We do the same thing there. We join these 2 points, and there we have it. So as I've said before, sometimes we allow learners to go a little bit out. So if you are out, then just remove those excess lines over there, and then everything will be fine. Is that clear? I spoke a lot. Is it fine?
Yes, sir.
Okay.
Yes,
So
sir.
now at some points I'll give you a shape and then we will ask you to draw in those locus of points at given places. And this is now normally how a question paper will look like, right? We give you a scenario with a dog and something and say, okay, the dog wants to go into his house or into his shed or wherever the dog is supposed to go. And then or the dog is tied to that place, he cannot leave the house. This is normally like a real life example where you want your dog not to bite other people, but to stay within the yard. If somebody comes into your yard, the dog will bite you. But if you stay out of the person's yard, the dog don't bite. Okay, and let's call this dog is a pit bull instead of now just this funny looking picture. So those dangerous dogs, that is what we have. So we want you to measure how long should this rope be that is tied to the dog so that the dog does not bite people in the street or in the neighbors' houses or anything like that. Only if the people come into your house, the dog will bite you. Okay, I just try to give you the real life scenario so that you at least see where do we use this in real life. Okay, so the Buster the dog is tied, I'll just call this tied by a 1 meter long rope at the corner of the shed as shown in the diagram. Draw and shade the area which Buster can move. Okay, so the shading, remember now, if we want to shade, I told you when we did the linear programming that in linear programming we are shading unwanted regions. Okay, unwanted regions is what we are shading. In Loci, we shade the wanted region. Where do we want the dog to move? We want the dog to move inside the yard, not outside. So outside will be unwanted. Okay, this will be unwanted. I'm just now putting it there. Okay, I don't want this. This is what we want. Okay, so in Loci, we shade what we want. We don't shade what we do not want. Okay, that's the only difference that we have there. Right. So also take note of that as we proceed. So over here, you will have noticed that once we draw the semicircle from this point coming up to that point over there, we then drew another one that is from here and this box here, and then we close it off there. So this one is slightly different than having a straight line because the shed over here is part of the boundary, or let's say the house here, and then the yard is now all these other places inside, outside that we have. So if you start here, you end there, okay? And if you come back to the top, I just had to mute there quickly. If you come back to the top here, it's now not anymore this point again. You have to start at the yard, counting the yard from this point over here. All right. So then from this point, we just continue where we left off and then we close it off. So that will be how the dog can move. All right. If you wanted to know how far it will move on the other side of the shed or something like that, that's also where it will stop. If it is tied here, if it was tied on the other side, it will work in reverse. Okay. So I hope that makes sense. And then once we are done with that, we just shade in the part that we want. And that will be the area the dog can move. And then this would have given you full marks. All right. So I think we will stop with Loci over here. The rest will just be questions that we will answer. I will post one question on the Google Classroom as well that you can attempt. So let us log off and log in for the next part of the session because I think our time is now up. So I will end this and then we will rejoin again.